by the way, this is your assignment 4. I've been I've been doing this assignment, testing it out. So this is your assignment 4. There's only 3 questions, and this last disaster planning is pretty tough. Just a heads up before next week. Disaster planning is pretty tough. But this is your assignment 4. Oh, and it only has 10 pages. That's a new low. Hi, welcome. There's a fun debugging exercise. Dodgers without orders, and then disaster planning. Oh, but I mean, Keith even gives you the pseudocode. Never mind. This question's not that tough, because Keith literally gives you the pseudocode for how to do the question. Cool. All right, how is everyone? Good? Okay. How is it week 4? Yeah, end of week 4. Are midterms coming up? Yes? Okay. How many of you are freshmen? Just curious. Okay, freshmen. And then everyone else, are you sophomores, juniors? Sophomores? Okay, cool. All right, so, Anna's not here yet. Well, so I know for the past lecture or so, I've been going a little overtime. I promise today I might even go undertime. So, just before we get to that, I want to start with a recap of last time. All right, so just a quick recap. Last time we talked about erasing in the SCL containers. So we talked about how if you erase an element, that invalidates some other iterators depending on what kind of a class you're using. So for example, for vector, because if you erase an element, all the elements have to shift down. All the iterators after that get erased. Okay. And then we talked about the problem of, okay, if you're erasing something, you want to make sure you can't increment an invalid iterator. So we solved that by using something like this. All right. Then we talked about, we'll go through this again today because we're going to use the actual algorithm today. All right, template functions. The goal of template functions is so that we can write basically different variants of a function which use different types, but basically share the exact same code. So the idea is, because you notice that the functions are exactly the same except for the type, you can replace that just by an arbitrary t and declare it as a template. Okay? Any questions about that from last time? All right. Yeah, so that's what a template is. And then you have to be careful about templates because it literally, if you don't specify the type, it literally tries to figure out what t is. And it isn't smart enough to do conversions for you. So if you use something like a C string, it won't do the type deduction correctly for you. Okay? Cool. Where just to check for understandings, is there anywhere else where you've used those angle brackets? Right. In CS106B, you should have already used something with the angle brackets. Yeah. Mm-hmm. 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 Yeah, you're exactly right. We've used these angle brackets when you're trying to declare an object of another class. For example, when you try to create your first vector, your first set, your first map, you've always used those angle brackets to specify what the type of that is. So the idea is kind of similar, where here we're specifying what type we want to instantiate this template with. Okay, and then you can probably guess these classes in the Stanford library, they are also template classes. All right, and then which means if you put some sort of type in there, it will instantiate that class for that specific type. Okay, we haven't talked about template classes, but we will soon in a few lectures. Okay, essentially you can extend all this to writing your own class where you can instantiate that class with whatever type you want. Cool. Then we did some examples. We turned some functions generic. I'm going to skip this because I'm going to talk about that again. What about implicit interfaces? Could anyone give a quick summary of what an implicit interface is? Anyone remember what an implicit interface is? Yeah, go ahead.
Or like the assumptions built into a function that you can define.
Mm-hmm. Right, exactly. So inside the function, there you're using your parameters in a certain way. For example, you might take a parameter and you might do this parameter dot size to get the size field, and then for templates, the compiler doesn't really enforce what kind of type you put into those template types. The only error that comes up is later inside the function, some piece of code doesn't compile because the type in which you instantiated the template doesn't satisfy an implicit interface. So the example for that was here. We talked about how for this function, even though the compiler doesn't enforce what input and data type is, what is enforced is how you are using this begin and this end type. Okay, so for example, here, begin, even though, we say input it, but that doesn't really enforce that it has to be an input iterator. What does enforce that begin has to be an input iterator is that we try to copy begin, and then we try to increment begin. We try to dereference this iterator. So that kind of enforces that begin has to be an input type. Okay, so that is called an implicit interface. Because of implicit interfaces, because these interfaces are not explicit, where when you are plugging in the type, it actually confirms that what you plugged in is an input iterator. Because it's not explicit, that's why you get these gigantic error messages. All right, and we did more practice. We talked about overload resolution. I'm not sure how many of you, I'm not sure how useful that was, but I thought it was interesting. I hope some of you thought it was interesting. But otherwise, most C++ programmers don't actively think about it. So anyways, let's talk about functions and algorithms. Last time I taught this, it did not go well. So what I did is I cut out an entire example. So today's lecture won't go over time. Okay? Cool. Let's talk about concept lifting part 2. So last time we ended with this function. Right? We wrote a function count occurrences, which essentially could solve the question, how many times does a certain type of a certain value appear in some range of elements? Right? Do we all recall this? Awesome. Okay, so here, let's take a look at this part, which is how many times does some type, some value appear in a range of elements, right? If you think about count occurrences, we're counting how many times a value appears in a range. But can we even generalize this a little more? We're trying to count how many times something occurs, right? Does it have to be how many times does a specific element appear? Okay, so for example, we can rephrase this as how many times does the element satisfy some condition equal value in a range of elements? Okay, this is another way to phrase what this problem solves. And what I highlighted green over there, that is something known as a predicate. A predicate is a function which takes in some number of arguments and it returns a Boolean. Okay, so you can see here that when we say something like equals 3, that is actually just a predicate, which is a Boolean function. It takes in an int and it returns whether or not that is equal to 3. Okay, what are your questions so far? Any questions about what a predicate is? Okay, so the idea is what we wrote in green over there, that really is a predicate. And in fact, we can replace that predicate with whatever other predicate we want, right? How many times does an element satisfy something in a range of elements? That predicate can be anything, right? You can ask, is it equal to 3? Is it equal to 4? You can ask even some broader range of predicates, like, is it less than 5? Is it greater than 5? All right. Any other kinds of predicates you can think of? Okay, so contains, sorry, it contains what?
Character, like, thingy.
Sure, okay, yes. So if we were going through, if the range of elements were like strings, then you can say, oh, how many elements contains some character? Okay, yeah, that would be a valid predicate. Essentially, a predicate is anything which can take in an element and returns true or false. And what our function does is it calculates how many of them returns true. Okay? And how we can change that code over here? Well, instead of saying just equals, we can now wrap that one in some sort of predicate function. Since predicate is a function, you want to call it like it's a function. So we're passing a function in here, some sort of predicate, and then inside there, we're calling that function on an element, which we get that element by dereferencing iter. Okay, just to make that more concrete, let's actually code that up. So everyone have the starter code today? So the starter code is fairly short today because the code is pretty short today as well. Okay, so let's try running count occurrences 5. Yeah, so here we have run this thing, right? We've run, last time we wrote, okay, we have a phone number, some number of digits, and then we're calculating how many times between the second half, begin plus size over 2, that gives us the iterator to the beginning of the second half, to the end. How many times does the element 5 appear? And if you run that, you'll get, I don't know, some 3, probably 3. Yeah, you'll get 3 because 5 appears 3 times in the second half. Okay, any questions about this first chunk of code we wrote here? Okay, but let's think about how do we solve the problem. How many times does the second, how many elements in the second half of the phone number contains elements that are less than 5? How many of them are less than 5? Okay, well, the idea is we can kind of solve, we can change our function up here. Currently, it takes in 2 iterators, and it also takes in this type, which it compares to. We can actually solve a more generic problem by saying, okay, instead of just taking in this data type, let's take in a generic predicate. So unipred, I'm going to change this to unipred. Okay, predicates are usually really small, so you don't really have to pass them in by const reference. I'm going to call this pred. Okay. Give me one sec.
Why do you call it uni?
Good question. So why do I? Okay, you know what? I'm gonna close this. I'm gonna reopen it one more time. Save, cancel. Okay, so why do we call it unique pred? Well, so what uni means is unary. Unary. Okay, so what unary means that this predicate specifically only takes in one parameter. Okay, so it takes an int at one int. Okay, for this function it makes sense because we're going to go through all the elements in our range, and we're going to call it on one element at a time. Okay, so that's why we call it a unary predicate. There are more predicates later where you might want to count you might want to take 2 different parameters in there. Okay, later on we're going to see a function called equal, where it essentially takes in 2 ranges. So 2 ranges, and it goes through the range and it checks if all the elements match in that range. Right, you can imagine here we're calling a binary predicate where we're checking if the first element here matches the first element here, second element matches the second element. So each time we take in 2 elements at a time. Okay, so yeah, there are instances where instead we take in a binary predicate where we take in 2 arguments. Let me close this because I don't know why it's a read-only file. Do not save. And let me open that one more time. Okay, just to make it easier, I'm going to re-download it from the. I'm going to re-download the file from the 106L website. There we go. Okay, there we go. So we are going to write the function. When I change this function so that instead of just taking in a data type, it takes in a unary predicate. It's small, so you don't really have to pass in the as a const reference. And then here, instead of checking if that element itself is equal to val, we want to check if when you evaluate the predicate on val, like this, it returns true. If it returns true, then you do the plus plus, count. Okay, and then there's an error here because now we're calling this function incorrectly. Let me comment this part out. Okay, so here, let's think about how we want to call this function. Okay, so our predicate function we've written over here, less than 5. I've written a predicate function over here. How would you call that? How would you call count occurrences? Count occurrences. Okay, now talk with your partner for 30 seconds. Figure out what the parameters for count occurrences are. Okay, go. All right. Also, starting next time, let's all sit in the first 5 rows so we can all talk to each other. But anyways, all right. So anyone have any ideas of what the parameters should look like? So what should the first one be? Yeah. So we want to put the begin iterator, and since we want to start from the second half, let's just say phone number dot begin plus phone number dot size over 2. Okay. Second iterator is the end one, so I'm just going to put phone number dot end. Is it called phone number? Oh, I even commented out the phone number. That's why. Okay. All right, and then what should our third parameter be? Yeah, the predicate function, right? So we're going to put this function, and we're going to put that into here. Okay. So yeah, remember that this is a function, but if you just pass in the name of that, it actually just passes that whole function in there. We're not calling the function, we're just passing the function as if it's an object, and we're just passing it into the function. And inside that function, then it actually calls the function by saying pred parentheses star iter. Okay? Question, yes?
Can we do this passing the function even if it's not a predicate? Like if we have some other helper function behind, can that be added as an object in other functions?
Good question. So the question is, instead of predicate functions, can we pass in any other kinds of functions? Yeah, the answer is yes. Later on, we'll definitely pass in many different kinds of functions. So it doesn't just have to be a predicate function. Okay. Most of the STL libraries use predicate functions because you're essentially trying to go over a range and try to figure out which ones are true, which ones are false. So most STL functions use predicate functions. There's one big exception, and that's there's a function called transform, which guess what transform does, right? Transform, it goes through the range, and it transforms each element by calling your function, right? So in this case, you wouldn't return true or false. You would that function is supposed to transform each element, turning it into something else. Okay. Good question. So yeah, this is a relatively new concept, right? Now we're actually passing in a function as a parameter, right? We've never passed in functions as parameters. Okay. And then the cool thing is the type of this unary predicate, what it's being instantiated with, that's actually kind of hard to figure out. Okay, I don't want to go too much into detail into what function pointers are, but the idea is that when you're passing in a function, you're actually passing in a function pointer, and then when you call this using the parentheses, you're actually dereferencing that function and then calling that. Okay, I don't want to talk about function pointers because we're going to move away from this really fast, because using this idea of writing a separate function is less than 5, and then calling it, that is not a good idea. Okay, and let's actually quickly discuss why that's not a good idea. So, yeah, so we called it using the predicate function, and then we can call this function with a predicate. Okay. Okay, now here's some problems. First, we literally wrote a function that's called is less than 5, right? Okay, you might ask, what if I wanted to change that to a 6 or a 7? Right now, we just have to write many copies of that, which is really, really bad. Okay, so if you were trying to solve this problem and you saw code like this, how would you try to fix it? Okay, that is a great idea. So here I would try to add, am I doing that? No, okay, yeah, but essentially you'd want to try to add another argument, right? You'd try to add, int val, and you also say, an int limit. and you'd say is val less than limit. Okay, yeah, that's a great idea. There is a problem with that approach, which is, let's go to this one. Okay, so if you try doing something like this, where you try to put some sort of limit, when you call this function, you'll actually get an error. Can anyone see why would you get an error if you try passing in that function right now? Yeah, because this function is a unary predicate. Well, it's supposed to take in a unary predicate, a predicate which you call in one function. But when you pass in an extra parameter, now it's no longer a unary predicate. It's a binary predicate. And let's actually just write that out, and you can actually see what the error message is, because this is one of the few instances where the error message is actually helpful. Well, okay, kind of helpful. So if I pass in is less than limit, okay, your first thing you should notice is, okay, we didn't even pass in 5, so that's going to be a problem. We never really said limit was 5, but if you try passing this in, what you'll get is, you'll see too few arguments to function call expected to have 1. And the error is here, where notice that how we're calling the predicate function, we pass in 1 parameter. We don't pass in 2 parameters. Okay? What this function does is it literally takes that predicate function and it tries to use it as if it is a unary predicate. And that won't work. Okay? Does that make sense? What are your questions at this point? Let's pause to answer some questions. No? Okay. Yeah, and then, oh wow, there's only 4 error messages. I expected more. Okay. So yeah, so that won't work. Another idea you might have is, yeah, and then you somehow need to get that limit into that function. You need to get the limit, that integer over there, into the function without using a parameter. Okay, that's kind of annoying, right? How do you get that into the function without using a parameter? Oh, so there's some suggestions? Okay, yes.
Maybe we can add the parameter over here in this function.
Oh, so you mean take that limit parameter and put that into the function? Into which function?
Like when the count occurrences function,
Uh-huh.
maybe we can specify.
Inside here? Okay, sure, yeah, so that's a good idea. So instead, we can change our count occurrences function to take in an extra parameter, right? Yeah, so yeah, that's a good function. That's a good idea. The problem with that is then our function doesn't really generalize well anymore, because you're not always wanting to compare that limit to some sort of predicate function, right? Yeah, we're not always going to be using a limit. We want to try to write our predicate function so that we want to try to write this function so it's as general as possible. Oops, wrong one. This one. We want to try to write this function as general as possible, and it's not true that we are always going to be using a limit. Yeah. So, yeah, that's a good attempt. But yeah, I thought someone was going to say global variables, because yeah, that technically is one way to pass in a parameter, pass in information without using parameters. And yeah, obviously don't use global variables. That's bad. I hope I don't have to explain that again. But yeah, so the problem is because this is a unary predicate, and the fundamental issue is scope, right? You need limit inside that function. You can't pass it in as a parameter. Let's talk about lambda functions. Question, yeah?
So just to clarify, templates will only accept unary predicates?
So templates will accept any kind of predicates, but because of the implicit interface, because of how we defined this function, right? In this function, we're using predicate as if it's a unary function. It's a unary predicate.
Gotcha. So if that inside of count occurrences, we had called the predicate with 2 arguments, then it would be a binary predicate in the template type?
Mm-hmm. Yes.
Well, it would expect a binary predicate?
Mm-hmm.
Okay,
Yes.
gotcha.
Yeah, so the implicit interface here is predicate should be a unary predicate. It should take in 1 argument. Okay? All right. And specifically here, it's expecting an int, because the predicate you're passed in takes in an int. But that doesn't work, so let's talk about lambda functions. Before, I had a slide in here, which is, so lambda functions started in C++ 11. Before C++ 11, to get around this problem, you would have to write your entire class, an entire class. To get around this problem, you code this thing called a functor, and that topic is dear and near to my heart because that was the topic I presented when I interviewed for this job. Okay, but I have to say, functor classes are a little outdated, so sadly I cut that out of out of the slides. But if you're interested in that, we can use that as a extra topic in the second half of the class. Okay? Yeah, there's a way where you actually write an entire class, and then you are able to save the extra parameter as a field inside your class. But anyways, that's not important. Let's talk about lambda functions. So right now we're using this old approach. This is called function pointers because if you go a little deeper, these are implemented as pointers. But how we want to do this instead is we want to use this thing called a lambda. Okay, so I'm just going to leave this here for like 10 seconds. Stare at it. Stare at it for 10 seconds. All right, I'm just curious. So what are your first impressions? Well, my first impression is I've never seen this syntax ever before. What the heck is this? Right? I mean, have you ever seen this weird syntax before? No, right? So this is really new, and you might be a little overwhelmed by the syntax right now, but we're going to break this down one by one to explain what each of these parts are. You can kind of guess what some of the parts are, right? I mean, for example, this is like a function body. You actually put just a function body in there. Okay? The thing to know is less than limit. It behaves pretty much the same way as what we had above. This is less than limit. This itself is a function object. It's a functor. And you can pass it in as if it's a function, and then everything else works. Let's break this down a little more. Oh, that's a little overwhelming. Yeah, so here are the parts of the lambda. Let's go through this one by one. Let's start with the easiest one to discuss is this parameter list, auto val. Okay, so this parameter list over here, auto val, is the same thing as this int val over here. Cool thing about lambdas, you can use auto as a parameter. In normal functions, you can't use auto as a parameter. Okay, so here you can use auto. Usually, I'm just really lazy, so I just put auto there. Okay. Second part, which is pretty easy to understand, this arrow bool. This specifies what the return type of this function object you're creating. Okay, so here it's bool because it's a predicate function. We had bool above us as well. Okay, just these two parts. Do you have any questions about these two parts? Okay, let's get into some of the more annoying parts. So, also the return type is optional. You don't really need to put this because the compiler can figure out what the return type is. So normally we won't write this at all. Okay, but if you put this, then the compiler will check that it actually returns a bool. Okay, but usually we just don't put it at all. All right. So what the scope of the lambda? This lambda, it has this inner scope in here where it starts with the parentheses and ends with the parentheses. Okay. Let's quickly discuss scope. So I'm going to quickly write this lambda function in here. Okay. So let's write a lambda over here. Okay. So what does a lambda look like? A lambda looks like this. Let's comment out is less than limit because I'm going to call it is less than limit as well. So auto is less than limit. Okay, so it first starts with this weird bracket thing. Let's think about that later. Auto val. We can optionally put this, but no one really puts that anymore. And then we just say return val is less than limit, where limit is, let's say, 5. Auto not allowed in lambda. Okay, my bad. So in C++ 11, technically auto is not allowed in lambda, but if I click on this dot profile and I change that to 17, that should fix things. No? Okay, 1Z. That should work. There we go. See, that error message just disappears. If you get weird error messages, make sure that you're in C++ 17. I think that was only allowed in C++ 14. Anyways, okay, yeah, so we declare the lambda. Oh, I made a little typo. Make sure you have a semicolon at the end as well, just like a struct. So now the thing you want to notice is, okay, it's still saying there's a compiler error with limit. So here's the thing about lambdas. Lambdas generate their own scope. They generate, they're sometimes called closures because they have a closed scope within them. Variables from the outside cannot be used as variables in the inside. So limit over there is not in the same scope as the limit outside, so that's why you get a compiler error here. Okay? If you think about this is like the exact same problem as what we had before, right? You can't pass in limit as a parameter. We can't just add a parameter here because that makes it not a unary predicate anymore. But we're also unable to get the scope in, to get limit in somehow. Okay, any guesses as to how to solve this? And just as a hint, there is one part of the lambda we haven't talked about yet. The square brackets, exactly. Okay, so this square brackets is, it's just sitting there, and you might be wondering what it's used for. The square brackets is called the capture clause. Okay, the idea is that square brackets is able to capture variables from the outside so that they're able to be used inside. Okay, so we literally just put the limit over there, and suddenly everything compiles. Okay, that's what I should put this above since we're going to call it here. Okay, that's what the capture clause is used for. Okay, just as just some more things. This capture clause, if you put it like this, it's captured by value. If you wanted to capture like a set or a vector, obviously you don't want to capture by value. You want to capture by reference. So you can put an ampersand here, and that captures by reference. Okay. Any questions so far? Yes.
Can you do multiple?
Multiple things to capture, right? Yes, definitely. So, I mean, it's not useful in this example, but suppose you wanted to capture a, let's say, total or something, 10. Okay, and suppose I wanted to, this is really cool. Every time I call this lambda, increment once. So this is really cool. Num times called. Okay, so every time this lambda is called, increment by 1. And I'm going to pass it by reference so that every time you edit it, this will change what is called out here. Did that work? Num times. There we go. Okay, and then here we do num times called plus plus. Okay, so this is really cool. Every time we call this lambda, that variable is going to increment by 1. And because we passed by reference, it's actually going to change this variable up here. Oh, I just thought of that. That's actually really cool. So you can actually see how many times this lambda is being called. Okay, yeah, so that's one like legitimate way why you want to pass by reference. Okay, just like all things, if question, yes?
So like the parameter type is auto, so how does the compiler figure out the type of is less than limit?
Good question. So I think, so basically if you put an auto here, what behind the scenes, what it does is it creates a template, which it basically creates this template t, and it replaces this with t. It basically does this. The equivalent of this isn't compiled, but it basically does something like that, where it treats that thing as a template, and then it just tries to infer whatever was passed in as the type.
So could you call is less than limit and like pass it in as a predicate for a double list as well? List?
Great question. So suppose instead here we change this to a double. So let's say this list was a double instead. They have to put point O's for all of them. But I mean, you get the point. If you change that to a double, this would still work because we would just infer that the auto here it should be a double instead of an int. That's actually a good point. That's actually a big reason why we want to use auto here, so that you don't have to create a new one for each different type you're calling on. Okay? Cool. Let's change that back to an, not there. We want to change this to vector of doubles. There we go. Yeah, and then this would still work because we're using auto here. Okay, so yeah, that's how you would call this. Obviously, there's just like in all programming languages, if you want to be lazy, there's also a lazy way of capturing stuff. You can use equals. If you do equals here, that captures everything by reference. No, sorry, by value. If you do an ampersand, that captures everything by reference. You can also do, okay, I want to capture everything by value except num times called, which I want to capture by reference. Okay? Okay, big tip, never use this because this kind of makes everything in the function kind of like a global variable. Everything is usable inside this function, which is not good. So in general, avoid this equal sign or the like. Don't capture everything using this or this. Okay.
Like, do you mean that like now can use every single variable called?
You can use every single variable inside this main. So you can even use phone number if you want. Yeah. Okay, obviously it's a bad idea because then you might accidentally use variables you're not supposed to. So generally just don't capture everything. Be selective, like only capture the variables you need. Okay? Cool. Questions? Yes.
So what makes is less than limit a lambda function? Is it the presence of the capture clause, or is there anything else that makes it a lambda function?
Good question. So it's the mix of the capture clause, and so when C++ sees this capture clause and a parameter list, it knows that it's a lambda.
Okay.
Yeah. Mm-hmm. Yeah. So because I think if you just do the bracket, I think there's some other use for just the bracket. I don't remember what, but I think there's a use for just the bracket, probably, right? Yeah. But once it sees this, it knows, okay, this is a lambda. I mean, even if you don't give it a body, you just do this. That works. It's just an empty function. Yeah. Any other questions?
Yeah.
Yeah.
So right now the scope of our lambda function is just within our main function.
Mm-hmm.
Is it possible to have a lambda function outside of main that is within scope of like the overall file that other functions can then use? In other words, can you move auto is less than limit out of main?
Good question. So if you do that, then it kind of becomes a global variable for this. It becomes a global variable, and then we haven't talked about namespaces, but you can actually wrap stuff in namespaces, right? Yeah, you can put stuff in like namespaces, and that kind of limits this global variable to a particular namespace.
Okay, so I tried to do that, and it's complaining that limit is cannot be captured
Mm-hmm.
because it does not have automatic storage duration.
So you're saying if you do
Yeah,
this,
move
if you move the limit as well, right?
Yeah.
Let's say here. Does that work if you do static?
No.
No. Okay. And do you have any ideas?
I tried to.
Const static limit cannot be captured. Okay. I think what the reason is that because if you declare it like this, there's this thing about like the order in which these are initialized in. There might be a problem with how these are initialized at the order. So I think because of that, that's why this might happen. Okay, I'm not fully sure how to solve this. I'm not an expert on how static works. Can I get back to you on that?
Yeah.
Okay. One final thing I want to show is that you can actually, just like functions, you can use default parameters. So I can say by default set that to 0. Okay, you can use default parameters and then, never mind. Okay, cool. Questions? Yes.
Can you have a lambda function in a header file and include that lambda function in other places? Like, is there anything special about a lambda function that makes it different than a regular function?
Yes. So a lambda function is an object. A lambda function is a so behind the scenes, there's actually a class that is made when you write this, and then it creates an instance of that class for you. So I think that might be why, like if you put it outside of a function, then there's this weird like static compile time thing where it has to create the class and it doesn't know what exactly you mean by create an object of that class right now. Yeah, this itself.
Yeah, so you cannot then put it in a header file and have it included by other functions?
I don't think so. Can I get back to you on that one? I'm not super sure. Yeah. Yeah. The reason is because this actually, like before, when I hinted that this is actually just a class itself, when I hinted that, yeah, this lambda, what it does behind the scenes is it generates a class. It creates an instance of that class, and that instance is less than limit. Okay. You might be wondering what is the type of this? Why do I use auto here? Here's one place where you literally cannot use anything else but auto. Okay? Because when the compiler generates a class, you have no idea what the class is called. The compiler is going to generate some name for that class, and then you want to create an instance of that. You have no idea what that class is called, so you have to use auto here. And that if I scroll over here, it says that it is some lambda. It doesn't even know until it tries to compile it. Okay? Cool. Yeah. So if you try running this would work. Questions? Yes.
So in a capture clause, you said you could use a default value. When would the default value actually get?
Yeah, that's a good question. Maybe you can't use a default value then. Okay, I'm not super sure about default values. I just suddenly thought of it, then I kind of backtracked and I'm like, maybe not. So let me get back to you on default values. Yeah, default values are relatively new, so I think they're like a really new thing. So I'm not really sure about that. Let me get back to you on that. Okay, but other than these details, do you all have a good understanding of how lambdas are made, how they're used? Okay, let's go through. Yeah, so you can capture by reference. You can also capture by value or capture everything like this. When I initially presented this, I had a slide which was like, Pokemon, catch them all. Yeah, so this is basically the catch them all symbol, the syntax for that. You literally catch everything in scope. Okay, I don't want to go over this. Should I? No, I'm not going to go over this. Yeah, so lambdas themselves, they're function objects, which means you can use them as if they were functions. So here you can see, okay, I declare a functor, a binary predicate, or not a predicate, just a binary function, and then we can call it as if it's just a regular function. Okay, I don't want to talk about bind because we're almost out of time. But if you want to learn about what bind is, let me know later. Okay, let's not talk about bind. Algorithms. Let's talk about the STL algorithms. So we finally reached the stage where we can talk about the STL algorithms. Okay, so what we literally wrote a function called count occurrences. That exact function is actually one of the functions in the STL library called count and countif. Count is the one without the predicate. It's the one where you just put some data value and it checks how many instances there are. Countif is the one which actually takes in a predicate. Okay? Yeah, so there are like many of them. There's a couple new ones. This is really cool. Some of them are actually run in parallel. So you can actually have it do count and it counts stuff. It counts different parts of the vector in parallel. Okay? Maybe we'll talk about that in the future. And there are many other algorithms. Here's an entire map of all the algorithms there are. Yeah, it's a big map. One thing I want to mention is there is a section for heap operations. Anyone know what a heap is? Okay, did you take CS106B before? Yeah. Okay. So there is an assignment 5, which essentially has you implement a heap, and you can actually solve that assignment in like 4 lines of code if you just use the heap algorithms. Okay, so just as an FYI, don't use the heap operations in assignment 5. Okay, you'll get 0 credit if you do. But just an FYI that there is a whole section of heap operations which lets you essentially implement a heap. All right, so let's just do some basic examples of algorithms. I'm going to go through some of the big algorithms that you might see, and then Anna will cover a big example of how you might use these algorithms, how you might use the entire STL to solve a problem. So here, let's just do some basic operations on some courses. Okay, so if you look at the starter code, you'll notice that, let me remove this because we don't need this anymore. What you'll notice here is that I created a struct called course, which takes in a name and a double. So the name of the course, CS106B, CS106L, and then their Carter rating. Okay. In the past, I would actually write like a file reading function, which reads in an entire file that I scraped from Carta. But I got lazy, so I really just wrote a bunch of courses. So you'll see that the CS core is in here. Some other common intro level courses are here. Yeah, and then some of the courses I took last quarter are here as well. Okay, and then it random shuffles it. Although it doesn't. There's no function called random shuffle. Oh, I think in C++17 it's now just called shuffle. There we go. Okay, that should work. No. 3 arguments. Why do you need 3 arguments? No.
That's where you should.
Okay. Well, anyways, it's fine. We don't have to shuffle. It kind of makes actually, let me just move some of this. Let me just change the order so that later when we're gonna call this thing called stable partition. That makes this a little cooler. Okay. So here, yeah, basically I've just changed the order of these so that later the partition will be cool. Okay. So let's discuss algorithms. So here this is a vector of courses. This is a vector of numbers. It's just a bunch of random numbers. And we're going to try some operations on them. So first, this is something that you might want to do. Here are some of the algorithms we'll explore. These are the really common ones that you might use. So first thing, let's do some processing where we want to try to find the median number in a vector. Okay, so any ideas as to how you would find the median of a vector? So if you had a vector of ints, how would you find the median of that? Okay, sort it, and then? Yeah, so and then find the middle element. If there's a tie, let's not worry too much about ties. Okay, let's just say there's some odd number of courses, just find the middle element. Okay, so the most common algorithm you will ever use is sort, which takes in the iterators of the range you want to sort. So numbers dot begin, numbers dot end, and then it just takes that in and it sorts the numbers for you. Okay. What else? Okay, let's say we want to sort the courses. So let's say we want to sort the courses by their rating. Okay. So if I did that, I'll probably get a compiler error. Okay. Any guesses as to we don't get a compiler error? That's odd. Okay. So I think what's happening is by default it's just sorting by. We should get a compiler error. Yes, we did. Finally. Yes, we did get a compiler error, and you'll see that the compiler error is kind of terrifying. Ooh. Yeah, it's what it's doing here is it's trying to call all sorts of sorts. The idea is this goes back to what we said last time about overload resolution. There are so many variants of sort. It tries the best one that fails, but then because of Sphene, it tries every single one, and it shows that all of them failed, so there's an error. So it has to go through every single one, every single sort in every single possible case, and it shows none of them work. Every single sort and every single instantiation of sort, none of them work. So that's why you get that terrifying error. And the reason for that, anyone know why we can't just sort the courses like this? It's a custom struct, right? There's no like default way to compare two structs. How do you know one struct is less than the other struct? So here you'd want to pass in a predicate function. See, this predicate function is called compare. What a compare predicate function should do is it should take in two arguments, and it should return whether or not the first one is less than the second one. Okay? So it should essentially implement what it means for less than, what less than means. So here, for example, let's write a lambda for that. So our lambda should take in auto, let's say, compare rating. It should take in two courses, let's say const course C1, const course C2. We don't really need the return value. And then we want to return what it means for C1 to be less than C2. So what does it mean for C1 to be less than C2? Great. So how do you know if C1 is less than C2? Okay, well, it means if C1.rating is less than C2.rating. Don't forget the semicolon. And then we can just pass this into compare court rating. Okay. I'm not going to just discuss what this is yet, but this is the fancy way to print stuff to see out. Okay, so if I print it right now, oh wow, everything is, see, it's from lowest to highest. Sorry, Chem 33. Sorry, Math 51. And yeah, and here are all the courses ranked by their ratings. Okay, yeah, I was going to Carta, and all the courses I thought of were too highly rated. So I immediately thought, Chem 33, let's look for Chem 33. And yeah, it's the lowest one. Math 51 was pretty good too. All right, so yeah, here are the ratings, and then you can sort them by default, okay? There's another thing you can do. What if I wanted to sort by the name, so I want them in alphabetical order? Well, you can just do, because these are strings, you can just compare the streams. Yeah, so instead, let's compare by name, in which case we'll get, yeah, the course is sorted by name. All right? Okay, and then just as you said, we can try to find the median. To define the median, we would do auto median is equal to courses dot, well, here we wanted to sort by rating, so let me change this to rating again. Here we wanted just to find the median, so we just find courses dot size over 2. Okay, if it's even, it might be a little off close enough, that's good. Okay? So this gives you the median course. All right. Oh, we're almost out of time. Dang it. Okay. Well, there's a faster way to sort. So sorting, we haven't talked about algorithmic analysis. If you've taken 106B already, you know that this takes n log n. There's a way to do it in O of n, and that's using this fancy function called nth element. We don't have time to go through this, but this is really cool. If you want to know what this does, come to us after class. Okay. Stable partition. So stable partition is really cool in that what it does is it looks at all the elements which the predicate returns true, looks at all the elements the predicate returns false, and it rearranges the vector so that all the ones that return true are at the beginning, all the ones that are returned false are at the end, and the internal order between the ones that return true and the ones that return false are the same order in which they were before. Does that make sense? Okay, so the first idea is basically all the ones that return true appear in the front, all the ones that return false appear in the back. Okay, and then the relative order of each of these don't change. So if two things which return true, one was before the other one, then after you stable partition it, the first one should still be before the second one, but all in the front. So essentially the idea is, if you take this, what does it mean? If I want to find all the CS courses, if I call stable partition, where my predicate says, is this a CS course? What happens is it's going to put all the CS courses in the front, not CS in the back, and the return value is an iterator to that partition point. Okay, so pretty nice to use, right? So let's just quickly implement that. Let's say we wanted to, okay, so it's 2:20. So everything else is probably just going to be like a lab time, I guess. So try implementing this yourself. You want to implement a binary predicate, which returns true if it's a CS class and returns false if it's not a CS class. Okay? Actually, it's a little complicated, so let me implement that. And then I want to make it so that it's a little general. It's not just for CS classes. So let's say is department, where I specify a certain department. Let's say here we say CS. So here we want to say auto element. Whoops. And then we want to return true. Why is there a weird syntax thing? Oh, I forgot to put the there. Okay. And then I want to say, okay, if the element, if the course code of the element, if that starts with, let's see, subster 0. Okay, this is too complicated. I'm just going to do CS. If element dot subster of 0, 2, that has to be equal to department. Return element dot size is greater than 2, and that. Yeah, there we go. Okay, so essentially the idea is std string. The idea here is we want to check if the first two characters is CS, and we also have to make sure that the size is greater than 2. Okay, so this checks if the element, the course we're checking, the course code starts with CS. In that case, we don't have to do the sorting anymore. Here we can just do stable std stable partition, where we pass in courses.begin, courses.end, and then we pass in is department, where it checks if it's a CS class. Run it. Oh no. What's wrong? Thoughts? No. Oh no. Oh, it's we want to check if the name size is greater than 2. There we go. Same thing over here. Dot name. Run that. Well, yeah, and you'll see that it's partitioned so that all the CS courses are in the front. All the non-CS courses are in the back. The relative ordering in them is also it remains the same. Okay, so that's pretty cool. That's a common function you'll use. Okay, why do we use algorithms? It's abstract. Okay, I'll briefly talk about this next time. Okay, another one is called copy if. So what copy if does is it looks at a range and it copies all the elements that satisfy a predicate into another function. Okay, so you might think to do something like this: CS courses.begin, CS courses.end. I want to put it into a new vector called CS courses, and then put the predicate there so it calls all the ones that return true. By the way, do you have any questions at this point? I'm going really fast. Basically, the idea is these are super useful, and don't memorize any of these. Maybe the really common ones, but you don't have to memorize any of these. And then you can always Google, like, you can always Google something. If you think of like an operation you want to do, and you think it's really common, there's probably an STL algorithm for it. Okay, so that's the yeah.
Is that code not work because the substring is not a memory? Like, why doesn't that code?
Okay, good point. Yeah, so there's definitely a bug over there, but this doesn't work because first, copy if takes in an output iterator.
Oh.
Yeah, so it takes an output iterator, not the vector itself. Okay, but even if you put the output iterator, that actually doesn't work. And the reason is this. Here's the reason. So let's say the algorithm is trying to copy stuff. So it says, okay, that's a CS course. I'm going to copy that. That's a CS course. I'm going to copy that. That's a CS course. I'm going to copy that too. I'm just going to keep copying, right? The thing is, the vector starts with a default size, but these algorithms, they're not member functions of the vector itself. So they don't actually have a way to change the size of that vector. So it just tries to write into the vector. It goes past the end iterator, and it just keeps writing stuff. Okay? The cool thing is you need some special kind of iterator which can expand the size of the container of your vector. Okay? So let me just write that out. Let's say we want it to do did copy if. Let's say we had a new vector. Let's say it's called vector course, CS courses, std vector, CS courses. Let's say we wanted to look at v.courses, courses.begin, courses.end. Our guess is to do something like CS courses.begin and then is department. Right, but this doesn't work because this iterator is not able to expand the size of the container. So to be able to find an iterator which does the size of the container, you basically just call this function called backinserter. Oops. And you pass in the container. Okay, backinserter is something called an iterator adapter. It takes in some sort of container and it spits out a special kind of iterator which is able to insert stuff. Okay, so here specifically what happens is, oops, not wrong one. So if you do something like this where you use backinserter on the vector itself, then you can do, then as it reaches this point, every time the iterator tries to write something, the container gets expanded. Okay? Does that make sense? Okay, I just want to quickly get that out of the way because that is really important if you want to use the copy functions. You have to make sure that you're actually expanding the containers when needed. Okay? Cool. Yeah, stream iterators, they're not that important. The idea is, let's say we wanted to copy elements into a stream, right? You can actually take cout and actually call this, this is a iterator adapter. It spits out an iterator for cout, which means you can actually write stuff to cout using the copy function. Here we're just copying all the courses and we're copying them into a stream iterator which writes courses, and when we just put them into here. Because we write it like this, that's why when this function is called, it's actually printing everything to cout. It's essentially going to the vector, copying everything into cout. Okay? Any questions about this? So these are just the really common functions you'll use. Copy, sort, copy, partition, and then there's one more, remove if, but do we have time to cover it? Okay, let's just quickly cover it. It's really fast. If you have to go, feel free to go. This is not super important. Last time we talked about how if you wanted to remove, what remove if does is it goes to the vector and it removes all the items which the predicate returns true on, right? Okay, so suppose we're trying to remove all the green ones. Last time we talked about this logic where we tried to remove like this, so you don't have to shift all the elements too many times. Okay, so, but the thing is, if you call remove if, let's say we wanted to remove all the CS courses. Okay, so let's say we wanted to remove all the CS courses like this. I'm gonna see out courses.size at the end, and I'm also gonna see out courses.size at the beginning. Okay, so we're gonna do this, and then we're gonna remove all the CS classes. We're gonna print all the CS classes, and then we're gonna print the size of the vector at the end. What do you think is gonna happen?
Will the iterator get involved?
Iterator. So the remove if is implemented so that it makes sure all the iterators are valid. So that's fine. The weird thing is remove if doesn't actually remove the vectors, the stuff. Oh boy, what is this? Is this the right one? Try running that one more time. Okay, so you'll see something weird is happening, right? The vector started with the size of 19. It does the whole removal thing, and then the vector looks kind of weird with some of the elements are kind of weird. And then at the end, the size is still 19. Kind of weird, right? Yeah, so what remove if does, remove if can't actually remove stuff from the vector because remove if is not a member of the vector. Key thing to note is the algorithms themselves, they cannot actually change the size of the vector. They can change the contents, but they can't change the size. Okay? So what remove if instead does is it efficiently moves the stuff move the stuff you want to remove to the back of the vector. Kind of like this. So basically after you call that, remove if returns this iterator to the beginning of the empty stuff. And this is the part you want to erase.
Why?
Mhm.
When you run it, there are two courses at the end that say CS.
Good question. So why are there still two courses here that said CS? So what remove if does is it uses some sort of algorithm to try to swap courses to the back, but there's no guarantee as to what these like removed courses at the end. There's no guarantee as to what there will be. The algorithm can do anything it wants to them. It just has to. The courses don't even have to be there. They just have to be. They just have to move all the courses out. The courses might not even be there. But the thing is, there is still like trash at the end, which you have to call erase directly so that the contents of the vector get changed. Does that make sense? Okay. So this is called the erase remove idiom, where you call erase on two iterators. The first iterator you call is whatever remove if returns. Remove if returns this iterator. And then you want to move all the way up to v.end, which is this. Okay, this is a really common, idiom. This is called the erase remove idiom. Okay, let's just try it once. Here, let's do courses erase, and then courses end. So if we run this, now everything actually gets removed. Yeah, so you can see that. It started with 19, the garbage is not there anymore, and it ends with 12. Okay? Yeah, so we're going to continue this streak of poorly named C++ functions. Okay, so last week we had svine, which is really poorly named. This week we had remove if, which doesn't actually remove. We'll have pimple coming up soon. And then, yeah, so essentially, yeah, a lot of these C++ functions, their names, they don't actually tell you what they do. Okay, so this is why C++ is hard to use for beginners, is because there's a lot of like little tricks to them that you have to have experience with to know, okay? But this is just one really important one that you need to know, which is called the erase remove idiom. Okay? I think I'm mostly done. One final thing I want to talk about is find. So Anna demonstrated find 2 lectures ago. Find essentially goes through a range and it tries to find the best one. Find the element that matches. You also need to know that for find, each of the classes themselves also have a find function. Which one should you use? It turns out that for sets and for maps, the find member function is faster than the find function than the std find function. Okay, I just want to put that out there. I'll recap that again next time. All right, thanks for coming. That's it for today. I still went out of time. Your homework problem is to actually implement remove if. Okay, it's actually kind of tough. Do I have the answer here? No, I don't have the answer. Okay, remove if is actually kind of tough. All right, thanks for coming. I don't have food today. I have my lunch here. But yeah, so thanks for coming. If you have any questions, please stay after class. Let us answer your questions. Yeah.
Also, so for Tuesday's lecture, that's sort of the last section in the STL, and that's where we'll be bringing everything that we've learned so far together. And please bring your laptops because we may actually try something new for that class. I'm not sure yet, but maybe. So bring your laptops just in case. Awesome. Have a good weekend, guys.
Oh wow. Okay. So the lambda stuff was interesting, and then algorithms are really boring. Like even just me talking about them, like, oh wow, they're so boring. Yeah. Okay. Yeah. Last time I had too many, and then these are the actual important ones. Yeah. So I hope that was. The what? Well, we didn't cover it last time, yeah, but because I think it's pretty important. Like you have to know how to remove stuff. Yeah.
So after I fixed it and I set like I is not equal to j, that still doesn't fix the issue. This is the wrong.
I think it's because you're going through each pair of I and j twice, right? I equals 0, j equals 1, and j equals 1, and I equals 1, j equals 0. Those are actually the same calculation.
Right.
Yeah.
But
so can you try to avoid duplicating that? Avoid having the case where you have I equals 1, j equals 0, and j equals 0, I equals 1. Or no, I equals 0, j equals 1. Let me write that out. I equals 0, j equals 1, I equals 1. Because these are the repulsive forces between the same pair of points. Right? Try to avoid that.
How does bind work?
Bind? Oh, okay. So how bind works? Bind is fairly simple. Bind is really helpful for before lambda functions were released. So suppose you still wanted to use this. Oops. Suppose you still wanted to use this function. Right. The problem with this function is that it has limit. It has limit to it, which and you don't want that extra parameter. So what you can do is you can take this function, bind limit to a certain value, and then it kind of collapses into that function, the first function.
Okay.
Yeah. So
it returns like a functor.
yes, bind takes a function and some parameters, and then it returns a new function which has all the parameters bound to the functor itself.
So if you have like a 5-argument function and you want to collapse it to 2 arguments of some function, can you bind like the second and fourth and fifth argument?
Yes.
What's the syntax?
Okay. Can you give me like 2 minutes? Let me just quickly demo this. So let me first do this simple case. The simple case is, okay, it's on the slides. Let me write it out. So the simple case is here. Okay, so you had that 2-argument function and you want to bind it so that becomes a 1-argument function. You would take that functor in. So bind takes an arbitrary number of parameters. Okay, and then you put the parameters in the order in which you want to bind the things. There are these special things. Yeah, I think they're enumerations. I'm not sure, but there's these special constants which represent don't bind anything to that one.
Okay.
So if you do this,
What is that? Is it like an Enoch constant?
I'm not sure. It's Google.
Question. What if I want to pass that value to the function?
Want to pass what value to the function? This thing?
Yes.
It's not a value. Don't worry. It's definitely not a value. STD. Yeah. Although now there's an argument of should you use bind at all, because the alternative to this is also you can also just write a functor which wraps your original function. Yeah. This is basically implementing bind. What exactly is the underscore things? Yeah, so you see like these like, oh, you can also like switch the order. You can also switch the order of your parameters. Yeah, but you can do like you can put them in different orders. You can put the same thing in two different places if you wanted to. What? Oh, here we go. What are these? These are called placeholder objects. See below. Okay, so their type is unspecified. They have unspecified type. Which means they're not defined by the standard. The compiler can pick what kind of type it is. Yeah, basically, I'm pretty sure they just create their own class, and then they don't tell you what the name of the class is, but then they just create some unusable class. But then you have these like global objects, which are of these unspecified classes. That's weird. Yeah.
So if I declared an argument of that type and wanted to pass a value, I have to have access to that.
Okay.
That's gonna be whatever compiler. So we're using what from GCC.
I'm really curious. Let's see. Is less than limit. Do you need to? Let's just try it out. So limit. Yeah. Let me check that out. Limit equals 5.
I'm sure this will break in some spectacular way, but
No member named
placeholders underscore.
functional. Oh, I didn't import functional. So bind is from functional. Functional. There we go. Okay, well, it's some constant. I don't know what it's. Placeholders?
Oh, yes, yes.
Okay, well, yeah, you get that. There's some constant. Yeah, there's some constants. I don't think you can do anything meaningful with them. I'm pretty sure it's undefined behavior if you do anything other than that with them. Yeah. But it's a really cool question because I don't really know what they do. I just know that you can use them as in the parameters for bind.
And then also
Yeah. Okay. Yeah. The functional namespace has a lot of really cool stuff. Yeah. It has yeah, I think although a lot of them are now like removed, like they're because of lambdas they're no longer needed. But in the past there would be like there's a function which takes in a function and it takes in a predicate function and it returns the like not of that function. So instead true becomes false becomes true. Yeah. There's a lot of different things. There's a reference wrapper. You use this in CS110 where you can take something and turn it into some sort of reference. There are a lot of these like basic operations, and then these are in C++20 ranges. Yeah. So that kind of gets into functional programming where you're taking functions and you're trying to compose them to create higher order functions. Yeah, I was going to talk about that, but then we're clearly always out of time, so no.
I did the staircase thing where
Okay, awesome.
j is equal to I plus 1.
Okay, and still doesn't work?
Yeah, so when I did...
Okay. Are you sure that
the math is right? I checked it a few times. I think it should be right.
can I see that vector?
And I ran it through the debugger a few times, and it does like go through this while loop. So it's I can't point to where it's messing up.
Okay. Are you certain that this thing works? That the draw nodes are correct? It draws it in a circle.
Oh yeah. So
okay.
When I run it for like
really short time. Okay. Oh wait, is it supposed to start like that?
Trend line? I have no idea. Sometimes it starts in a circle.
Okay. You try rolling like 0 milliseconds.
And what does the vector contain? Has single numbers? Okay. So
Yeah, I guess it starts like that.
Yeah, it's not supposed to start like that. So check your math for draw a graph.
Well, I did just
So actually, first question is, what is
draw
this first
draw
line?
nodes.
Draw nodes, yeah.
I think this is right. 2k pi I.
Is it nodes minus 1 or nodes?
It's the number of nodes, so shouldn't it be -1?
Number of nodes should be num nodes, right? Yeah, I think it should be num nodes.
So then you'll read from that vector you created 2 at a time. Okay, that totally works. Yeah,
So maybe
that
this will
works
fix it.
functionality wise. So now your question is, what do you want to do with that information?
Yeah, it works.
So
Kind of.
there are 2 things you'll need to do.
I can't get it to
So
animate
again,
though.
the
It's,
purpose of this whole first step
Oh,
is
it's
to
because it's
set
running
up
too
the
fast. Can you try running cube?
and to set up the
Cube?
graph,
Yeah, writing cube, yeah.
you
So the
set
way to
up
check if
the
you're right is
initial
I always use cube in
you're
10
setting
line.
all of the initial positions of
It should look like a
nodes,
cube.
and then you're setting all of the nodes that are connected by n.
Okay.
is it because I'm
So
entering a
the
time too
graph
long?
takes 2 parts.
No,
that-
no, that's not going to be a problem.
How do you set the
Yeah.
initial
Okay.
x, y positions of all 3 nodes? What do you think?
All right, can you submit your code and then I'll take a look at it. Yeah.
Okay.
Yeah, because I have to go, but yeah,
Oh, I
submit your
can
code.
ask
Anna, okay, yeah, ask Anna if you can't figure it out, submit your code and then I'll take a look. Okay.
What does the 0, 1 represent? Perfect. So this is actually sort of tricky because this information is completely separate from the 6 nodes information. Notice that we could have a file that just says 6 and then nothing else because there's no